Okay, we're looking at the second half of our lesson for the fine Monday morning, or Tuesday if you have a B day, on adding and subtracting polynomials. Honestly, you've been doing this before, right? Let's just look at it in detail today. Let's talk about like terms. Like terms have to be exactly alike. I also like to say, like, they have the same last name, or they're the same family, right? So let's just say I have these families. I have the Smith, Smithers, and Smithson. Now, they look like they're very similar, but they are not the same, right? Often like a squared, and a to the third power. They look alike, but they're not the same. And when we're adding and subtracting polynomials, it's not like our multiplication rules where we could just add up the exponents, right? This is just adding. You can only add like terms, right? They're similar, but they're not the same. Well, let's just talk about matching some like terms, right? If I have the first column A, let's see how they match up to B. So I have negative 4AB. Well, the last name is AB, so I have to find the AB, right? If I were to combine these two like terms, I'd end up with 3AB. 7a to the fourth matches with 3a to the fourth. And 3b matches with, 2b. 2a to the third power. Do I have any a to the third powers? No, I do not. It doesn't have a match. Negative a. Well, of course, a is just a, and it matches with the other 5a, right? And if we were to combine those two like terms, we would end up with 4a. And 5a is also by itself. So when I'm adding and subtracting monomials, I am combining like terms, right? So they have to have the same last name, right? So here I see that 15m to the third and 2m to the third have the same, or I can combine them to end up with 17m to the third. But 6m squared is totally different. So I combine the like terms. It's the same thing as adding. And of course, I want to put it in standard form with my largest degree first. So if I have 3x squared plus 5 minus 7x squared plus 12, I have to look at what's in common. These are both the same last name of x squared, so I'm going to combine those like terms. And then 5 and 12. So I go ahead and combine my like terms and end up with negative 4x squared plus 17. So this big long stretch ends up becoming a binomial. Two terms, two people in the family, because there's two separate last names, right? So two people. All right, let's go ahead and combine these like terms. I have 2xy squared and 3xy squared. I can combine those to get 5xy squared, and then negative x squared y can combine with positive x squared y, and they disappear, right? They cancel each other out. So I end up with a monomial after all that. So when I'm adding polynomials, again, I'm combining like terms. Now, in this situation, I have a binomial, and I'm combining that. I'm adding it to a trinomial. So I have to see if there's anything in common. These two are in common, so I can end up adding those together, and a negative x and a positive 3x, when I add those together, they also have something in common, but the negative one is by itself. So I go ahead and combine these like terms. Inside my head, this is what I'm doing, but of course you can skip this step, right? Because it's obvious, hopefully. So often when I add a binomial and a trinomial, I end up with a trinomial, right? Because I'm combining some sort of term. Let's look at this one. We have negative 2ab plus 2ab plus an a plus a b. I'm just going to end up with, you got it, a plus b. Now in standard form in this situation, we put at alphabetical order, a plus b, not b plus a. So again, when you're adding, it's just combining like terms over and over again. It's pretty common sense. You find everything that's the similar, and you combine those terms. I like to combine them in this was a polynomial over here, so I'm going to simplify first and then go ahead and add all my like terms. And it melts down pretty fast. Now, subtraction is where people get a little messed up because they forget that when this little subtraction bar means this, it means you're actually kind of like distributing a -1, right? Because you have to subtract it all. Subtract it all. So you have to really watch that. So you want to change it to adding. In order to change it to adding the polynomials, you distribute a -1. And now I combine my like terms, negative 4x squared and 2x squared, and then 4 minus 2. So I end up with negative 2x squared plus 4. So once again, when I'm subtracting a binomial and a trinomial, it's like there's a -1 there and we have to distribute that. We've had some practice in this already, so I'm thinking that you will be pretty successful. Then we combine our like terms. All right. Sometimes when I'm taking a quiz or a test on combining like terms, what I like to do is I like to stack them up with each other, right? So I'm going to give you this you try, and then I'll show you what I mean by stacking it up. So go and pause your video here. Okay, so what I like to do is when I see this is a -1 here, right? I just make sure that I'm going to change this to a positive. So I distribute my negative and my negative here. And then I just write the like terms underneath the other terms. So this is a negative 2x squared. And here I have a negative 5x, right? When I do this, they are already matched. And I can see that I'm going to combine these and this, right? And it's more like the subtraction you did as a kid. 3x squared. Oh, that just goes away, right? And then plus 7. Easy peasy, lemon squeezy, which you can see why we did 6, 4, and 6, 3 together today.